So in this session, I'm going to teach you the remaining part which we left on the yesterday class. With the help of Python, we do cover one by one thing, how to implement all the concept of statics using Python. All right. So I'm just opening my Python notebook. I put my notebook on what we say in pandas folder so that I can access the dataset. All right. I only demonstrate the mean on yesterday due to problem my thought. So I just complete everything today. Uh, Try to complete what I gave the PPT presentation. I'll try to complete today.
Can you share me the data, sir? Yesterday, due to some network issue, I couldn't continue
Mm,
after.
no, I don't use a new data set. Everything is old. I use a diabetic data set. All right, no new data set.
Okay,
Okay, so
okay,
I just demonstrate very starting. The thing which I taught the very first is mean. Okay, so cell and run all, so that okay. So what I do, first of all, put the pick over here. What is mean? Mean just average. What data set you getting from there? That is a mean. So I import the numpy pandas because I will use two library to call this function numpy and pandas and manually. I also demonstrate the manually. First, in last class, I create the 100% data of 100% whose height whose weight is varying from 30 kg to 70 kg, and these are the 100. So I create a population of 100 one. Okay, so that is created, and I try to implement its weight. So what I do, I initialize with sum with 0, add all the weight, sum all the weighted, then print the sum, and then divide by the length of weight. So we have 100 peoples, divide by, so I got a 49.15 as an average. Okay, average means mean. We find the mean of this one. All right, all right. In the next sequence, what I do, again I increase the sample by 100%. So when initially there was 100%, now it is 200%. So as a statement of center limit theorem says, how many increase are taking a sample? So increases around the mean value. The mean is around the mean value. So you see the both sample have the mean 49.15 and 49.35. All right. Now functions to calculate the mean value. We have np dot mean using a mean one, and if you're using the data set, so what happened? Data frame is also data set is also provide means the pandas is also provide you the function to get the mean. All right. If anyone new in this session, Hariyo Mishra, anyone new in this session? Very new. Okay, no problem. Okay, so okay, we get data set, and I also demonstrate describe function. Describe function give you all statistical data, so it also provide the mean. So using pandas, I demonstrate the mean. Using pandas, I calculate all the value numpy. Numpy also demonstrate its a mean value, and we do this thing manually. We do this thing manually. We take the glucose column, sum all the glucose, printing the summation of all glucose, then divide by total number of length of glucose. So we have same glucose mean what is returned by the describe function. Okay, and we do this thing manually. Similarly, if we want the plot of all the things, so we see the glucose mean is very high. I take all the columns, take a blank list which contain the mean, and append all the mean over there. Then we plot bar horizontal to show this. This is the thing which we do on yesterday. Okay, anyone know? Okay, so now the today's topic after mean, I will turning toward the median. All right. So what definition I put? for the median, I will first show you, then I moving toward the median one. Okay, so the median, what is median? Median is the middle number, but that number will be sorted. The data should be sorted. Okay, so what I do, first I collect the median, I mean the image for the median, so that you can easily uh, check over here. Hmm. Two cases are there. I told you when I do present my slide, two cases are there. Hmm. Yes. So which one is better? First, I take this thing. How to calculate the median? First, try to what data we have to put in ascending order or sorting manner. So the point exactly middle on this one known as the median. But what happens sometimes when we have number of data is odd? That's like we have 1, 2, 3, 4. 1, 2, 3, 4. We have 9 entry. So you can easily find middle one. But you have when even entry. When you have odd entry, you can find easily middle one. But you have even entry, let's say 10, 12. So you have to find two numbers on middle one. So in that case, what we do, we just take the average of two middle number. Just like you can see over here. This is the good way to check this one. Mm, copy image address. Alright, you can see over here. If we have two number, all right, and then you find the one number is getted, so the number allocated in between, that is a median. When you have two numbers, so you have to take the mean of that number, that is looks like your median value. All right, so now what function which is used for a median, to calculate a median? So first one, the np dot median. Let me take the data set. I hope I have weight. Okay, if I want to find the median of this one, these are 200%, 200% data set whose weight varying between 30 to 70. Okay, uh, I thought you are doing with me and same data you are working. If you gone through here, check this one, 30 to 70. Why I put the 71? Because the last point is never attended, so it's going to 30 to 70. These are 200. Now if I want to calculate the median value, so what I do, I just put np dot median, then I pass. So it says, see, it's a 200. First is sort the thing, then collect the between two numbers, then take the average. So its median is 48.0. Okay, using pandas, you can also calculate the median. Just for example, if I am taking df dot head, I hope my data set is df. Okay, so what I do, I directly implement df dot glucose, the column name, the median. Mean I demonstrated yesterday, median 117. And same median you can find in this, what we say in describe method. Hmm, I think median is not available in describe function, but you find over there. One second approach, what happened? You draw this glucose value, convert to numpy array, and pass this in numpy array. For example, I take again glue1 equal to df dot glucose dot values. When you put the values, it convert to numpy. Then np dot median, then glue1, same. So you can access this one, pandas function, or you can access this one. You can access your own, just like I do this thing manually, just like I calculate the mean manually. So you do your own. Okay, so this is the task for you. Design a function later on. I mean, you can do after the class. Design the function which return you the median of given sample, median of given sample. When you designing a function, keep two things in mind, two hints in mind. Number one, total count. Number two, sorting of data. Sorting of data. Why total count? Because if you have odd number, so just length. Let's suppose if I have 9, okay, so for example, see what I'm trying to say. Here the total count play important role. If you have a length is 9, okay, so you have to put length by 2. What happened with that? You get 4.5. Sorry, we have to take collection. Let's suppose any length is 9, length by 2. Okay, so what happened? You have a length of 9. 1 2 3 4 5 6 7 8 9. So 4 here, 4 here. This will be your median when you have odd number of things. Let's suppose 9 element are there. So you have to collect this one. So what you have to do? Take this thing as an integer, 4 plus 1. Means you have index, you have to generate the index. So in that sense, index will be the total length by 2 plus 1. So when you print the index, so you got the 5. Means on fifth index you have your median. So when you design a function, put the two things in mind. You have to put the total count for the median. You have to sort the data. I mean, otherwise, the ready-made function is available.
Sir,
All
one
right.
question here.
Yes, please.
Sir, is it good to sort our data? Will it not affect the quality of the data, sir, if we start sorting it?
No, I'm not getting you. I mean, a median work on the arranging of data.
No,
Median
no,
will,
sir.
yeah.
No, yes, sir, yes, sir, yes, please, sir.
So if you have a random sampling, so what median says? Median says you have to first sort the data, then find the it's a median. So what your question is over here? Now tell me.
Okay. If we are sorting the data, does
Hmm?
it affect on the quality of the data? I mean, will it affect on our final predictions or any such kind of things, sir?
No, no. First thing, we are sorting in the sense we are not modifying our original data frame.
Okay, okay,
When if you attend my pandas lecture, so see when I do the sorting, I never manipulate, never put in place equal to true parameter.
okay, sir.
Keep in mind, so I always create a temp means temporary. I all perform all the operation on temp. So it is not recommended to disturb your original data set. Okay. But if you want to retrieve the result, make it copy and show your result. Never do this thing. I never recommend to put in place parameter. Those who don't know the in place parameter, just reflect your result in the original data set. That is not recommended. Okay. So I should always make a copy and then do this work. Otherwise,
Sure.
everything is shuffled in that. Okay, particular
Okay.
those column value will be shuffled, those are mapped. Let's suppose if I do sort the thing, so what
Okay.
happen, every other rows become on in place, but this glucose will be sorted to smallest to largest one, so that is not compatible. Okay,
Right.
so we have not to do this thing, but I just put over here the hint for the index, how to got the middle value and how to got a middle plus one value. Because in the case of even number, you got two middle number and then you find the average of this one. Okay, in that next sequence we have mode. I hope all of you read my slide, all of you got my slide. Yes. S-
Yes, sir.
so Tejashri, what is mode, how we define the mode?
Sir, I'm so big.
Shobik, no, I'm just asking to Tejashri. I mean,
Okay.
Tejashri, how we define the mode is there?
Yes, sir.
Yeah, please
The
tell.
most free,
Yeah.
the most frequently Present value is the mode, sir.
Modes. I mean, any data in any data, the number is repeated mostly time. Frequency is very high. That is mode. Okay. So there is two way to getting this mode. Okay. So first way, uh, first let me put the image mode so that you can directly hit the value, the concept. Okay, this is better. Yeah, 555. Yes. Okay. So if I want mode, I mean, this one is over here. So if my df is there, df dot head, if I want mode of glucose, okay, so one function, I mean, that is not a mode, but that reflect you the thing. So if you remember df dot glucose, I told you dot value count, if you all remembers. All right. So this thing will be reflected you in glucose column, how many numbers are repeated and what are the frequency, and that is in decreasing order of frequency. So you can see the 100 glucose value repeated 17 times, 99 repeated 17 times, 129 repeated 14 times. So we have two mode in the sense of glucose, because both are in tie condition. Okay. So if you talking about the formula, what formula you have, just put also head also, because it will always give you the first five occurring number. So 199 two modes are there. But if you're talking about the function split for mode, so I'm using the statics import mode. What happened?
Sir, it's from statistics, not for, I
Importistics.
think so.
So it's from
It's
statistics.
Yes, yes,
from
yes, yes,
statistics.
yes, yes. I never do attention from FROM. Perfect. Okay. So we have weight again, but one problem we have with this function. So what problem we have with this function, that if we use, first of all, I'm showing the problem. I'm using this package, stats package, and using a mode function. If I'm taking df dot glucose over here, this give me error. Why this give me error? Okay. No unique mode found, two equal common values. Means mode is there, but they are in tie condition, because they are conflicting. Two number have the highest frequency, 100 and 99. Okay. So this function have a problem. So always if you find this kind of thing. Okay. Now we come on the mode on what we have, the weight sample. So one number that is occurring many time, that is 67. Okay. Hmm. If we control F67, hmm, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times is occurring. That's why it is a unique one. If other one occurring 9 times, so this will give you the errors. Okay. So these things keep in mind. You will never got this kind of thing. Okay. The pandas function, dia dot glucose. Mhm. We have df dot glucose dot mode. Now what this function do? This play an important role. This is showing that you have a two modes, because here we not concerned about the frequency. Here we concerned about the mode. Here you have a two mode. The first mode is 99, the second mode is 100. Similarly, if you go on to the next column, means this function give you the error because of two are conflicting, two are tying to have the same frequency. Value counts display all the frequencies with the value, but mode function of data frame give you the two values and says that it is have two mode, 99 and 100, because there is two mode, explicitly two mode. That's why I always use a value count to counting a value with the frequency. All right, similarly in next sense, if you take the mode of blood pressure, 1. So let's check this function. Let's check mode function to check this one, because now it will not conflicting. So what I do, mode df dot blood pressure dot values. Oh, I mean I will work. I think it's a work on this. Either you pass this way, entire frame, or you pass the values. Values convert anything in NumPy. So both are. So what I do, I put here three function. Number one, the value counts to finding a mode, that is indirect function, that is pandas function, then stats function. You can find over here. Now, coming into population and sample. Someone knocking my door. Nihar, Mr. Nihar. Okay. Population and sample. All right. So population LATION and sample. Hmm. Which one is best? Yeah, I hope that is best. Yes. So again, what I taught you in population and sample, what happened is mm, somewhere no sampling, no sampling. Yes. Okay. So how to create a population? How to draw a random sample? The thing is behind this, we are not considering from one end. We are just picking one to find out the characteristics of each one. One is blue, you're perfect. One is black, black repeated two times. Okay, so let's get do this thing. How to create a population? A population, creating a population. Remember these function play important role. Okay, these are not directly concerned with stats, but you have to keep in mind what function create a population. So what I do, again I use a random integer. Let's suppose I'm creating the height of person, height of Indian people, height of height of Indian male person. Okay, so what I do, I take a variable height equal to what I do, np dot random rand in height start from, let's suppose I'm starting 150 centimeter, and my height is going to not 150, 150 more, 130, and my height is going to 130 to 181. All right, now I am collecting the 100 person. This is not percent, person, 100 male person. Give me their height, and what was their height? These are their height. Okay, you and me have a different thing because they're random points. So maybe you and me a different thing. Okay, so this is my population, but I take the pop population because something resemble the words population. Yeah, that's perfect. All right. Now, how to get a sample of this one? Okay, check this one. I'm creating a four sample. Okay, sample one. Sample. We have to select means according to me. I mean, any considerations there. I am selecting 25 random point in given population. Keep in mind, I am selecting 25 random point given population. Okay, in sample one. So I take the sample one equal to np dot random dot choice. Choice, choice. What this method do? This method need a collection. This method need a collection, any collection, and give you total number of data point. Let's suppose I give the pop and I need 25 random points in the given population. So this will give you the sample one. This will give you the 25 randomly point. Just like I take 152. After this, it take somewhere 167. Where is that 167? Hmm. Oh, you guys can search me 167. Yeah, it takes second point over here. After 130, this one 163. Hmm.
It's in first line.
No, no, back first line. Okay, means the thing is distributed somewhere. Okay, so once 163 is over here, 152 over here, and 130 over here. So choice function give getting an sample. The same way I take the sample again. I'm getting a sample for, but it is not necessary for a single point of original population that it may cover any of sample. It may cover or it may not cover. Okay, sample two again 25 points. Sample two, see 154. Take sample three, uh, sample three, and sample four, and sample four. The motive behind create these all. What is motive behind? First, I do calculate the mean of original sample. Okay, this one. First, I calculate the mean of original sample. Means these are the person, and I have a height of this one, height of 100 people. So what I do? Okay, so what I do calculate hmm, m mean under population pop. Okay. Similarly, what I do, I take np dot mean mean. Here I pass the pop. All right, same way I'm calculating all the mean, then I do visualization. See, then I see that is the mean of each individual is turning toward the mean of population or not. What we do this with help of center limit theorem. Means if we take the mean of any sample, the real time example I given on yesterday, when the election result is come in India, so they take sample or they take survey on small sample, and then they impose that result of sample on entire country. Okay, then we try to see what happening with this. All right, so mean, yes, mean of sample one equal to what I say, the np dot mean. Okay, I pass here sample one. All right, doing perfect. Yes, again copy this one. We have four sample. Control V and control V. 2, 3, and 4. 1, 2, 3, and 4. All right. Now we have mean of population, mean of sample 1, 2, 3, and 4. All right. Now, I'm using the bar chart, plt dot bar. Like plt dot bar first contain the name of axis. So have the population, then sample 1, name given to x-axis. Okay, so population 1, sample 1, sample 1, sample 2, sample 3, 3, sample 4. All right, these are name given to my x-axis data. All right, second list. What second list contains? Second list contains this data. This one again, 2, 3, control V, 4. Yes, perfect. PLT dot show. Before this, I just put the PLT dot X label. PLT dot X label. We have the what we say name of mean. That means whose name. I mean whose means I'm taking. Okay. PLT dot Y label, mean value. Now, guys, now you can see this is original population mean, then sample mean. See, my intention behind this, the all the sample reflected near about the same mean, which you have the as the original one. This is your population one, is sample 1, sample 2, sample 3, sample 4. If you want to see this thing manually, if you want to print this thing manually, so you also have its figure where somewhere here. Will print it or not? Yes, it's a tuples form. First one is 156.92. That is a mean of population. 154 sample 1, 154, 196. Very good. So this sample just little bit higher by 6 point. Otherwise, all three samples is showing it. That's center limit theorem very important. If I am taking anything from any sample, I can impose that thing on entire population because all sample exhibit or reflect same thing over the given data. The main thing which is reflected by the sample. So whenever you take this thing, whenever you take this kind of thing, mean any of the, I take the mean of height, you take mean of weight, you take mean of marks. So what is average thing? So I'm suggesting you based on this given thing, at least do prepare one thing for me right now. Based on the given thing, create a population, create a mean, and do visualize this thing right now. You need any code? I just give you two code. First of all, the population. First of all, the population. Then I'm giving you the choice. I mean sample. Okay. Then for the mean sample. Then for mean. So I'm giving you 2 minutes. How to calculate means of there and do plot this thing.
Sir, can you repeat your question?
माय क्वेश्चन इज दैट जस्ट हाउ जैसे कि मैंने वेट का लेके बनाया है, आप किसी भी एक पैरामीटर को लेके बनाओ और चेक करो कि मीन उसका पॉपुलेशन मीन के अराउंड आ रहा है, द सेंटर लिमिट में प्रूव हो रही है या नहीं हो रही है। मेरे केस में तो प्रूव हो गई कि मेरा पॉपुलेशन का मीन मेरे सैंपल के मीन के इक्वलेंट ही आया है, अप्रोक्सीमेट इक्वल आया है। ठीक है ना? यू अंडरस्टैंड? यू टेक आई टेक द हाइट, यू टेक द वेट, यू टेक अगेन हाइट बट डिफरेंट पैरामीटर। माई हाइट इज अराउंड द 130 to 181. You take the height of different range and check the mean of sample is around the mean of the population or not. Just 2 minutes there, counter start now. TikTok. Yes, yes, please.
मुझे एक एरर है, आप क्या स्क्रीन एक बार दिखाएंगे?
हाँ बताइए कौन सी लाइन में, मुझे सेल नंबर बताया करो, है ना। जब भी आपको कोई दिक्कत हो, जैसे सेल नंबर 42, सेल नंबर 43।
द लास्ट कोड।
अच्छा ये वाला बार प्लॉट वाला ना।
हाँ हाँ।
आपने गड़बड़ क्या होगा, आपने गड़बड़ किया होगा कॉमा सेपरेशन करने में किया होगा। 5 वैल्यूज हैं, 5 वैल्यूज हियर, 1 2 3 4 5। ये आपको चाहिए तो मैं आपको दे देता हूँ ये, है ना।
हाँ सर, मैं किया हूँ।
नहीं नहीं, अब देखो जरा कहाँ पे दिक्कत आ रही है। मैंने शो कर दिया है। अब देखो फटाफट, क्योंकि ना ये कोड ज़्यादा है थोड़ा सा। ऐसे कर लो। यस नो। यस, टेल मी व्हाट यू डिजाइन। Take the sample of glucose that given the data set. Take the population as a glucose and create some 5 6 sample, then get its mean.
सर फिर भी एरर आ रहा है, मीन पॉप इज नॉट डिफाइंड।
Mean of क्या रह रहा है, mean of।
मीन पॉप इज नॉट डिफाइंड।
मीन पॉप आपने बेटा ये रन नहीं कराया होगा। जब आपका सेल रन हो जाता है ना, तो यहाँ पे ना सेल नंबर आ जाता है। सेल, ये सेल आईडी आ जाती है ऐसे करके, जब भी रन होगा। अगर नहीं होगा तो कि ऐसा एरो बना होगा केवल। आप ये देखो, ये सेल रन है, उसे प्रिंट करा के देख लो, मैंने यहाँ प्रिंट करा दिया।
हाँ सर, अब आ रहा है। हाँ,
थैंक यू सो मच।
मैं रन नहीं करवाया,
हम्म।
मतलब
ध्यान रखें कि इन चीज़ों का रन कराने के
प्रैक्टिस
बाद,
कर।
रन कराने के बाद इसमें आईडी एलोकेट हो जाती है ना। इनपुट आईडी, आउटपुट आईडी।
हाँ
जहाँ प्रिंट स्टेटमेंट होगा वहाँ आउटपुट आईडी आ जाएगी। प्रिंट नहीं होगा तब भी आउटपुट आईडी आ जाएगी, अगर आउटपुट आप प्रिंट करा रहे हैं तो।
सर, मैं क्या स्क्रीन शो करूँ? वो
न-
ग्राफ जो दिखा रहा है
नहीं नहीं,
दिखेगा
आप
या नहीं?
आपका आ गया नहीं है, अराउंड आया ही नहीं है, बार हाइट सेम आई है।
हाँ, ऐसा
बस बस
ऐसा
बस
है।
बस बस अपने आप को ऑनेस्ट रहो, है ना। बाकी या हिस्सा वैसा चीज़ दिया। आशीष सोलंकी गिव मी एन एंटायर कोड। ग्लूकोज चॉइस, चॉइस ठीक है। कितने सैंपल बनाए, 4 बनाए आपने। आशीष, एवरीथिंग इज फाइन।
Yes, sir.
Okay, that's good. Okay, 30 seconds remaining, and remaining people do attend, please. Done. ये सबका हो गया, काइंडली कंफर्म मी, यस यस यस। सब ऐसा चीज देयर और नॉट देयर। Okay, okay, that's good. Any person find the mean is having a too much difference, sample mean having a too much difference. uh Too much difference means the data you are getting over here around this one. Just like one bar is there and one is there, that is too much difference. But in my case, all having around the same one. All right. Now what is standard deviation? Please look my screen. Now the next topic is standard deviation. Okay, so we have one block, that is good side, math is fun. All right, there's a good side, math is fun, very good block is there to understand the standard deviation. Okay, let's see the problem, then find a solution. First of all, two things are there: variance and standard deviation. Okay, so standard deviation is a measure of how spread out number are. Mean for a given mean value, how much the number is spreading out. Let's suppose there's a given mean value to and fro. How much number is spreading out? I'm just catching you in 1 minute. Okay, please wait. Just I'm coming in 1 minute. Okay, so where we are in standard deviation. So what I'm saying that any data how much is spreading around the mean value that we measure by the two quantities. First one is standard deviation, second one is variance. So keep your mind here. We have good example so that you can learn these two factor forever. Okay. So what is variance? Variance is the average of square difference from mean. Okay. Don't learn this definition. I will show you the mathematically. Okay. Very good example. See, consider we have one, two, three, four, five dogs. All right. Okay. So we have to find the variance and standard deviation. Okay. So the height of shoulder, I mean different dogs, 600 mm, 470 mm, 170. These are given because we are gathering this population of dogs, population of any sample. So we have to find these two parameter: variance, how much data far away from this one, and what is it? Squared sum. Okay. So what do we do? First of all, I calculate the mean. I take height of each dog one by one, then divide them by total number of quantity. All right, I found this one. That is 394 is my height. All right. Now, what I do? I draw a line of mean. This is a line of mean, the green line. So what happened? Some height is above this and some height is below this. All right. So the above height give you the positive difference. But what about the negative one that give you the negative difference? Uh, I keep this thing in my mind that two class ago I told you why we make the square of the errors. Same thing I am doing here. Check the things. Around the mean, what height of dog is positively difference? What height of dog is negatively difference? If I add them all, so what happen? If let's suppose some dog have the plus 2 and some dog has a minus 2, they will cancel out each other. So total thing is 0, but entire you have 4 units, 2 units here and 2 units here. So to ignore this thing, ignore this spreadability of data around the mean value, we take the square of this thing. What is the advantage of taking a square of this thing? Because the minus sign is going to be eliminated. Okay. So what we do? Whatever the height, 206 square, 76 square, minus 224 square. So this is by sigma square, variance by sigma square. Okay. Then when you take this one, divide by this one, so you got 21704. So now come on definition. Well, now come on the definition of the variance. Variance is defined the average. Average means divide by total number of data points by the square difference from mean. You are taking the difference from means, mean the sample value, any value x minus mu. Okay, and then you put the square. Okay, so when you difference the thing, let's suppose you divide the thing, when you get this quantity over here, those quantity get the square. 206 got the square, means the actual value minus mean value. That's the thing, actual value minus mean value. So now what formula you getting over here? And we put this thing equal to sigma square, because we are removing the minus sign from the spreadability. That's why we also taking a square. That's why we put a sigma square. So this will give you some average of a given model. See, this is my model. I have five population, five dogs population I got over here. Okay. So the function which is used for a variance of a given one known as a var. Okay, np dot var. So let's demonstrate this thing. Let's get this data. 600, 400. Let's get the data and see what variance it is returning to me. So first of all variance, then we calculate the standard deviation. Variance, variance, skip m, and what I do, I just put the same image. What same image? This same image, this better image. Variance. Remove this thing. All right. All right. I mean, the symbolic presentation is there on the mean value. So I take the list of dog where I contain the data, this data, this data, this data, this data, and close the list. Okay. So when we get the np dot var 21,704. All right. Same variance you got over here. All right. So what about the standard deviation? When we have this quantity and I want to calculate this one, I want to calculate only sigma. So I take the square root of this one, square root of this one. So when you take the square, so means average. Okay, some more. Okay, so the good thing about the standard deviation that is useful. Now we can show which height are within the one standard deviation. Okay, so you can find which height if you want to put the one standard deviation means around the mean value. If you do the one standard deviation, which height come under this one. Otherwise, average given average, how much one dog is navigating around the mean value average on and one average. Okay, so keep this thing in your mind when you see the variability, how far data is spread out the mean value. Means just for in your colony, just like where your house is there, so how far, how number of house on left side and how much number of house on right side. So that is not same, but we have to keep in mind this median range, this what we say, not median, it's a mean range. Okay, so average 147 and average 147, these are the revenue known as the one standard deviation in which the dog's height is lie. So the function used for the standard deviation is known as the std. Okay, the same data we pass over here, np, this is not suitable place, I just remove this one over here. So np dot std standard deviation, you put the entire data list. All right, so the given data frame df dot head, you only got the standard deviation, you only got the standard deviation when you got the df dot describe. Check this one, std, all stds can be plotted over here. Either you go this thing or you can get two things, np dot std. Let's so check df dot glucose. Another way to find this one, np dot std, the df dot glucose. Another way, or use np dot glucose control z dot values. Same way. So based on this one, design a function in Python without using without using any var or std function, var and std function, to calculate variance, variance and standard deviation, and standard. Okay, you have to design this thing in Python. Okay, once you design, pass the data, do it home as a homework, pass the data, same data, and the thing is reflected over here. All right. Now, in the same sequence, I put the homework, otherwise, thing will be mixed. All right. Now, the range. What is range? How to tackle the range? So, for the range function, I'm again picking any image. Yes, that is a better image. All right. So what range do? Range tell us how far our data is spread. What is a minimum point? What is a maximum point? A given data, you can find range easily. For example, I have to use a two function. I have to use two function. One is max, one is min. To calculate a range, calculate the range, I have to calculate two function. First one is min, minimum value of a given sample, and then maximum value of a given sample. All right. So let's see. Minimize the mark. Okay. So if I'm storing GLU glue2 equal to glucose dot values. So what happened? Range equal to range 1 equal to np dot max glue2, that is a collection of my glucose point, glue2 2 minus np dot minimum value, again glue2. So go on to the range 1. It says, so what is a minimum point and what is a maximum point? As 199, what is a minimum point? Okay, design a function. Let's design a function. Def calculate range. You are accepting any parameter. Let's suppose you are accepting x. So what you do? First of all, calculate the min. Mi double n min equal to np dot min. What we put x over here? Again max equal to np dot max of x, then return and max minus, sorry, max ma double x minus min. All right. So this is my function to calculate the range. Now, if I pass over here for testing, uh, calculate range. I pass away df dot glucose. Oops. Perfect. I want to calculate the range of blood pressure. Perfect. So what is the minimum maximum point? If you go to the describe function for the blood pressure, so minimum point is 0 0 and maximum point is 122. That's why it is reflecting 122. Here minimum 1, any point, yeah, is perfect. Is minimum is 21 and maximum is 61, 81. Okay. So I'm just passing the age over here. calculate range at df dot age 60. So same function which I designed over here, you have to design just like a standard deviation and variance. All right. Now the most important thing, interquartile range IQR. IQR inter. All right. So let's see what is interquartile range IQR. I will give you these all blocks which I use following over here. Try to capture the math is fun, very good website. Very easy representation gives you interquartile range. This one, quartiles and interquartile range. All right. Okay. So first understand what is quartiles. Okay. So what is quartile? Quartiles are the value that divide list into quarters for any range, for any data. We have three quarters on 25%, on 50%, and on 75%. These are three quarters. Okay. Put list of numbers in order, then cut list into four equal parts. The quartile are the cuts. When you make a four equal parts, one, two, three, four. So these cuts known as the quartiles. But thing is that you have to put number in order. For example, check this one. Copy image address. Check this one. These number are put in order. So what happened when you put number in order? So first of all, count the number. One, two, three, four, five, six, seven. Puts first of all median cut, that is on 50%, that is known as Q2. Again, put the median cut because the number seven number, one, two, three, four, five, six, seven. So you can easily find the middle one. So on middle you have five. So 50% or the median value or second quartile or 50%, all these things are same words. Around five. Again, on the left side of this thing you have three numbers. Again, you can easily find its cuts. It's a middle value. That is first quartile. That is Q1. That is 25%. On right side again you find three numbers. Again you find a 75%. But now students are wondering that if we have even numbers, so what we do? All right. So first of all, check this one. Q1 that is on 4. Q2 which is also median, then 5, and Q3 quartile 3 is on 7. Now what about the even case? That is a case for uh, odd, and there is a case for the even. I both put all the things. All right. So what happening over here? First of all, again we find the middle one. So now number is not the odd, number are even. So how much? One, two, three, four, five, six, 7, 8, 9, 10. These numbers are sorted. Keep in mind. So 10 number are even. So you find two middle number. Okay. So whenever you have two middle number for the middle quartile, so take its average. 5 plus 6 by 2. So your 50% of quartile 2 is 5.5. So if you capture this number, so what happened? I mean, you are here in between this one. So one more side you have five numbers. Let me close the thing, otherwise everything is overlap. So one side you have five number, easy. In five number you find the middle one. Here you have five number, again you find the middle one. So according to a number of total number is even. So you got the first quarter on 3, second quarter 5.5, third quarter. Same thing, same thing you got in the box plot. Same thing you got in the box plot. How? How you get the same thing in box plot? You box plot working on these quartile with the help of whisker. All right. Based on this thing, we have IQR, interquartile range. Okay, you got any quartile to any quartile, Q3 minus Q1, this range. You can got this one, you can got this one, any quartile to any quartile range. All right. So, so which function gives me this data? Good. I mean, the concept is working fine. That's good. But which function this give me data? Okay. So let me plot the first thing, the box plot. Where's my stats notebook? The concept is clear. All right. Now I'm drawing the box plot. SNS dot box plot. Better first of all, I'm taking the df dot describe. Why I'm using this function? Because this function contain everything. Now you can mine this thing. 25, 50, 75. You can find over here. Okay. So how we calculate this value? What are the function which reflect in this one? Okay. So I'm taking the value course one more time. That is glue 4 equal to df dot glucose. Okay, in glue 4 I have all right, and put the values so that you can put the all the things in the form of list. Glucose 4 mm, values values. All right, now perfect. Okay, so first of all I want to calculate the 25th quartile. Okay, so the function which is used for this one, I just disclose over here, np dot percentile, percentile. First, it will ask a data on which data you want to make. So my data is glue 4, and which quarter you want to make. I take 25th quarter. So check this one. It's a 99. Check these value for a given value 99. Similarly, go on with the 117, 140. Similarly, Q2, you put simple of 50% over here. Put the Q2 117. Similarly, put the 17, means Q3. All right, put over here 75, 140. Let's check these are 140 or not. Perfect. Okay, so the same value is reflected by the box plot, because box plot working on these kind of quartiles. Okay, so SNS dot box plot, what happened? I just take df dot glucose, or I take y equal to df dot glucose and data equal to df. Oops, comma missing. The first quartile 99, you can show over here. It's a 99 around the 100, then 117, then 140. Check this one. So using percentile function, you can easily calculate what is saying the interquartile. You can subtract Q3 minus Q1 if you want to see it's a interquartile range IQR. IQR, you put just Q3, the quartile 3 minus Q1 to get the that range. Okay, so you can easily find data range over there. All right, this thing are we cover. Okay, one more thing is the normalization. What do I put over here? G point.
So can you show the box plot once? I will
I
check.
hope you missed the Seaborn class. Is it? That's why you are not getting properly.
No, no, now it's okay. No, I just checked it.
Okay,
It's
okay.
okay, sir.
Then two things are there.
Sir, you can switch.
Okay, thank you. So yes, what we do, I just promise you for the G function how to take data in normal form. Where's my G value? Yeah, okay. this thing I want promise to. Okay, so the score is given over here. So everything is ready made in my scikit-learn library, which I escape, and I promise I will cover all data pre-processing technique in machine learning part, but here is a time to explain this. Okay, so what happened if I am calculating, yeah, checking the distribution of what we say glucose and its range, its value. What I do over here, I just take SNS dot dist plot. What I take df dot glucose and hist equal to false. Hist means I not need histogram. I just only KD, the distribution line. All right. Then PLT dot show. Hist equal to false. F capital. Check this line. Check the range. That is 100. Okay. Check the range over here in slide. That is the main thing. Check this slide. The bell point on a zero, above zero, means the mean value I shifted over here on zero. So two things are possible. How we do this thing? Two things. First thing, we do normalize. Normalize. For normalize, what I do? I use a min max scalar. Min max scalar. Okay. Let's see. I'm importing from sklearn. I mean, this is a new library used for the using machine learning. From sklearn uh, dot pre-processing processing import min max scalar. All right, so let's move the documentation of the min max scalar. When you want to see, I see scikit-learn is very important library. It's contain all the model, all the thing. This is min max scalar. So see its function. Okay, it calculates the standard deviation first, then use the formula x minus x min. It's working on vertical columns. All right, let's see the behavior of this curve after applying the min max. I take min max equal to min max scalar. All right, so what I do, my values over here. Okay, so what if I store the glucose value first in a variable? That's better. So I take glue 5 equal to what I want to show you. I want to show you transforming values. All right, then I pass here the glue 5. Perfect. Okay, now I take glue 5 normalize. All right, so I take dot fit transform. Fit transform is a method which just change your values and pass all the values. I'm not modifying the original one. I'm just creating a replica of this one. All right, what happened? Oops, it stored take the two-dimensional array. Okay, so what we do in that case, I have to transform entire the data set. Yeah, it take the two-dimensional array. Hmm. So can I use this thing? Glue form is converted to the two-dimensional. Uh, hmm, glue 5 dot reshape. ISHAP reshape. What happened?
Sir, glue 5 space n you have given, I think.
No, no. Glue 5 is
Not,
my numpy type now.
no, no,
Glue,
sir. Down here.
glue 5.
Down, yeah. Here you have written no sir. Acha, okay, okay. I can
No,
see
it
that.
is not accepting the one dimensional.
Acha, okay.
Okay, actually it is accepting a two dimensional. So I don't know number of rows and columns also. So let me check glue 5 dot shape.
Sir,
Shape.
sir,
Yes, 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 dear.
you can do under bracket, like third bracket.
Let
Do
me check.
under.
Let me check that. Done, done, done. What I do, I take entire row and one column. Now it is two dimension. Okay. So see what I do. Don't be confused. What I do, first of all, I store all the values in any variable, then plot this variable. All right. Now, what happened with this? I have to put here any variable glue 5 underscore mm, numpy. That is in the numpy. Yeah. Now I pass glue 5 underscore numpy because this is working two dimensional. Yes, perfect. So two dimensional data because it accepting the two dimensional parameter. Now check the values. Check the first value what it shows to you. I mean, the first glucose value I think is 200 somewhere. That is 148. Once the thing is normalized, now normalized value is converted to 0.74. So what about this curve? You will got amazing that how good transforming this value. I take the same thing over here, and I put the variable name glue5n. Check the ranges. The value which are very higher. Now once the normalized, now it comes between 0 to 1. So that's a use of min max scalar. Any value, any higher value you can turn into smaller value given 0 to 1. So what happening with normalized data? The advantage the training become fast. You cannot eat the big things, but you can eat the small thing very fast. Okay, same thing. So this is one way you are tending towards 0 to any positive number. That is one. But what if you want to put your origin on 0 and you are tending towards this one? In that case we use a standard scalar. Okay, so what I do from sklearn, I will teach you separately uh, in the data preprocessing chapter in machine learning, but here I want to show you how the data is shifting their origin. Okay, sklearn, when we talk about the g function, because the g function same as the standard scalar, the function has the same value x minus mu upon standard deviation. Okay, so the same value we have a standard scalar dot pre-processing standard scalar. So again take a standard scalar equal to uh, what we have a standard scalar sts equal to standard scalar. Then I again take the original value, which is my original value. Where is my original value? My original value is two dimension value, glue 5 numpy. Okay, I check this one. uh, I store this thing in any variable glue 5 underscore standard tandard underscore scalar scalar equal to sts, the fit transform just change all the values. All right, now again I'm showing the same curve, and here pass the standard scalar values. Check this one. The bell thing or the median value comes on a 0. So this is a technique how you want to store, where you want to put your data. So half value goes to minus and half value goes to plus. So if you want, I mean, just first go the documentation. Same function which you do, uh, calculate if some function is there, not. I think we go with the, yeah, check this one. X minus mu upon standard deviation. Same working done the standard scalar. Rather than you go the concept, you go the formula, which I showed my in slide. The thing is behind, you put the mean on zero. Same follow, obtain x minus mu upon standard deviation. Same formula you can got over here. G equal to x minus mu, or u upon s. So you can find these kind of techniques now develop in machine learning part. Now libraries are developed so easily, so can you plot different kind of normalization. I first normalization I put the mean on zero, and second normalization I reduce these value up to zero, between zero and one. Min max scalar. Minimum value is zero, maximum one. You can put minimum value zero, maximum five, depend upon need. So that is for today. I hope you learn very new things today regarding stats. Rather than implementing same concept, so I taught you something new things, so you can find. Yeah, where. Mm, uh, I will share this thing. You actually, you have to advise, strongly advise to do this thing, okay? Because there, most thing you find the output. What kind of output is changing? Value is same, shape is same, but origin is going to x shifted. Zero, zero to one, and originally you have the original distribution. So how long 200 values are there? Now you are decompressing the value, compressing the value, or changing the value, or transforming the value in a desired thing.
Hello, sir.
Yes, Savik.
So we can do dot reshape minus one comma one
Yeah,
too.
definitely, definitely do. But this is easiest one, and you can, because many things, many person will confuse in the minus one. What is the concept of minus one? In my NumPy, I never taught you minus one about that. I just taught you the reshape as take the first of all number of rows, number of columns. So what number of rows are there? Number of element are there? I put in number of rows and vertical column. Now become two dimensional. Many taxes are there. You can use this one. But easiest one is this.
Okay.
Any more question?
Hello, sir. Malikarjun here.
Yeah, Malikarjun, your question is very long time. I think you missed 10, 12 classes. Yes, yes, please.
Yeah, so how we need to use this code?
You are present in last class.
Yes,
So first of all, you have to normalize data. For normalized data, see, many things are there. But here, my intention to how to find the data on normalization, normal distribution curve. So that's why we use the G score. Means you put your mean on zero. That's why. Second thing, when I taught you the confidence interval, to calculate the confidence interval, we need a G score. You was present in last class.
yes, sir. I yesterday also.
Make it notes there. You have to learn these things. Okay. See, stat.
Because
Yeah. Please speak.
yeah, here some power problem is there. So yesterday as well as today, I am using in my mobile, sir.
Okay,
Yeah.
okay, okay. No problem. Okay. So, any more questions? Otherwise, we can. Let me take the attendance. Let me take the attendance first. Yeah. Yes, you can speak, please. Mm-hmm. Mm-hmm. In that case, you have to show your screen. I mean, lots of people got the exactly. Okay, okay. So, chat box. Okay. So, Okay. Okay, you take the 100. Okay, let me check here.
768 points are there, so around 100 points.
Mm-hmm. This one, and this is cutting. Okay, that's why I'm asking somewhere it is even differing. I have
Like
to put a
DI.
D. I have to put DF over here. Okay. How many points? How many points in 768?
768.
So what about you take the 7 sample?
Okay. I just tried it with 5
Seven.
samples.
Take the 7 sample. Take the 7 sample, or better you take. See how much sample you take. You take the one,
5.
2, 3, 4, 5. Please put 763 by 5. You
Not
take
going
one.
to sir, 120, sir. It
You
is not
take
one.
you take 125 points. Just take and tell me 125. 125. Random to choice 125 means if you are not attending approximately all data points because it is picking the random wise. Some points are zero. See, practically zero glucose is not possible in anybody. Hmm. Glue one. Okay, perfect. Check mine code also. Bar horizontal, then plt dot plot. Let me check. Hmm.
Actually, sir,
More
right now,
difference. More
the
difference.
sir, scroll up, little bit scroll up and
हम्म
you plot with the box plot.
बॉक्स प्लॉट इसका
Or
तो
go
मैंने
to
कहाँ प्लॉट किया है प्लॉट किया मैंने ग्लूकोज का मैं ध्यान में नहीं
yeah. Yeah, now, sir, just see, sir,
दिस
maybe, sir, it from the
इज क्वार्टाइल दिस इज
no,
क्वार्टाइल
no, 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 box plot you आपने plot किया sir. थोड़ा
हाँ ये
नीचे आ
रहा
गया
हाँ
of glucose, sir. See, sir, there is some outliers. So because of these outliers, it helps sir, in that because there are so many extreme values in that glucose data.
तो उसको
So
ये कवर कर रहा है दैट्स व्हाई ट्रिम्ड दैट्स व्हाई आई टोल्ड यू ट्रिम्ड वन इन दैट केस वी यूज a trimmed one somewhere uh,
sir, is this that for reason, right, sir?
yeah that is the main reason. That's why I'm asking you where you have lagging, I mean difference. So we have to use remove that thing, and you can go on through the continuous point. The value continuously start from there. Because 0 0 0 what happened? See, zero is very dangerous thing. I told you what happened. What happened is you have 100 zero concept. Take the mean. What is the mean? 100. Perfect.
Yes,
When you add zero, now how many point are there? Two. So
yes,
what is there?
but
50.
the value doesn't increase. Yes, sir.
Means zero doing nothing but zero just
Yeah,
changing the entire concept. So that's why zero is something problematic. Otherwise if you have 10, 20, 30, they will do some small contribution, but zero is not doing any contribution. Lots of zero in their check. I don't know how many zeros are there, but lots of zero in the given column. And zero, zero,
yes,
zero, zero, lots of zero is there, but practically zero glucose is not possible. Okay, so you can remove this zero.
so
Filled.
for sample, so we can generalize that whenever we do sample,
Hmm.
we don't mean for that overall data set or population, right?
Yeah, yeah. Better you take a filter. Those glucose value greater than zero. Then try means exclude zero. Only exclude zero. Nothing else. Uh, After zero, you got to start from because lots of data point is overlapping over here or lots
Yes,
of zero. So you start from something I don't know 30, 35. Then try this one. Exclude zero. How you exclude filter? Do filter means those glucose values is greater than zero. Then you draw this chart on this one. Then
okay.
so you can find that these things are never be so much differentiate. All right, thank you dear.
Instead
Yes.
of dropping the zeros, we
Hmm.
can replace it with mean, sir.
That is data imputation, but see when we do the population and sample, data imputation is not applied. Data imputation we just trim.
We are using those data, sir. So instead of
uh,
that,
uh,
no
in
actual
my
one.
in my opinion statics data imputation is not applied. We just either remove or include the things. All right, either good sample or bad sample. Okay, so as far as my knowledge is statics concerned, replaceable is not. Yeah, in machine learning part, we do every task, no rules there. We have to find the optimum accuracy, so we do anything in machine learning because we have to find the optimum thing. But in stats, never I read the replacement. I thought I'd never read the replacement of these things. All right, but data imputation work very well in machine learning. When we do the data pre-processing tasks, we do these things. All right, any more question?
Thank you.
Thank you. It's your dinner time, it's my dinner time. Thank you so much.
Sir,
Yeah, anything's remaining from your side? Yes, please speak fast.
yes sir,
Sir,
IMG सर IMG SRC करके जो इमेज लेना है ना, वो
हाँ,
मैं आपकी तरह क्या ऊपर एरर आ रहा है, मुझे
वो
समझ नहीं
इसलिए
आ रहा है
वो
क्या।
इसलिए एरर आ रहा है क्योंकि सबसे
तो
पहले तो
मैं
ये
क्या
सबसे
स्क्रीनशॉट।
सबसे पहले सुनो मेरी बात सुनो। सबसे पहले तो ये एक HTML टैग है। HTML टैग है। दूसरा लेने के बाद तुम्हें क्या काम करना है इसे हाँ हाँ आवाज आ रही है। फिर तुम्हें मार्कडाउन करना है, इसे मार्कडाउन बनाना है, फिर रन करना है, तब इमेज आएगी। तुमने सेल में पेस्ट किया। सेल में पेस्ट
सर
करने के
आपका बात ना कुछ कट जा रहा है।
नो नो आई एम स्पीकिंग वेरी लाउड एंड क्लियर। आवाज साफ आ रही है?
नहीं, मेरा शायद इंटरनेट का प्रॉब्लम है।
ओके, तो आपको क्या काम करना है मेरी बात सुनो। सबसे पहले आपको ये पेस्ट करना है, फिर मार्कडाउन कर लेना है, फिर रन करा देना है। बस इतना सा काम करना है, इमेज आ जाएगी। ठीक है।
ओके
यस
ओके
सौविक,
ओके।
यस सौविक, व्हाट यू आस्किंग?
हाँ थैंक यू
हाँ
I'm
सर।
not asking. I'm asking the code uh, which shared by Sobhusachi, I think.
हाँ 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 हाँ। क्या हुआ उसमें?
Yeah, there was a mistake in the code.
हाँ
Like
फिर
you see that glue and then when he was taking the
यस यस यस
mean
यस
glue,
यस यस यस
it was
यस
mean
यस
glue, and
बट
in the bar,
let me check अभी। दिस इज चैट बॉक्स इज नॉट प्रॉपर प्लेस टू चेक। वी चेक ओवर हियर। सो वी टेक glue 1, glue 2, glue 3।
just
वो नो।
there one has to change that mean pop plot dot bar
नहीं सही तो है।
dot mean, sir, mean pop. It's
देखो पहली लाइन में इसने ग्लू कैलकुलेट किया, पहली लाइन में ग्लू कैलकुलेट
yes,
किया।
no, sir.
mean glue.
That list,
फिर
sir, in that list when I implemented plot dot bar horizontally, the first function, the second list, the first index is that mean pop, sir. That mean glue.
Sir, that is mean glue. Yes, exactly.
सही तो है।
नहीं सर,
नहीं नहीं
मीन पॉप है।
mean
वेरिएबल
pop है।
वेरिएबल नेम चेंज करना होगा।
तो
नहीं
रिजल्ट क्यों दे रहा है? क्या मेरा उसका वेरिएबल सेम है क्या, तभी रिजल्ट दे रहा है?
फर्स्ट आर्गुमेंट सर,
नहीं
फर्स्ट आर्गुमेंट
करके
राइट
दे
इक्वल
रहा।
टू।
बट एक जो प्रॉब्लम इससे निकल के आई, मुझे पता नहीं कहाँ कोड है, एक जो प्रॉब्लम निकल के आई वो ये प्रॉब्लम निकल के आई कि जीरो जो है वो दिक्कत कर रहा है यहाँ पे इस टाइप
सर
का कभी
ये
कभी।
सर एक्चुअली प्रॉब्लम जो है ना कोड में है, उसमें कोई दिक्कत नहीं आ रहा है। आपका
लेकिन
जो
इस कोड के बहाने एक चीज नहीं तो पकड़ में आएगी अगर जीरो हो तो। अच्छा बताना मुझे जरा कहाँ पे है, सही कोड भेजो ना फटाफट से।
ओके
फर्स्ट लाइन करेक्ट है, सेकंड लाइन करेक्ट है, ये लाइन करेक्ट है, सही ना?
सर, जो
हाँ
प्लॉट
सर
का
हाँ।
फंक्शन है,
हाँ हाँ
प्लॉट का जो है,
हाँ हाँ।
तो y का जो आर्गुमेंट है, y
वाई
लिखता
हाँ
है,
हाँ हाँ हाँ।
y
सर इन
जो पहला जो फर्स्ट आर्गुमेंट है मीन पॉप का,
हम्म।
तो
मीन
प्रीवियस
अंडर
आर्गुमेंट
मीनर्स ओके, लेट मी चेक। ओके नो प्रॉब्लम, सही आना चाहिए फिर तो मैं क्या देखूं। लेकिन
हाँ
ये
सर,
चीज एक चीज
सही आ रहा है सर।
एकदम सही आ रहा है।
हाँ, लेकिन वो चीज एक जो पकड़ में आई, सामने आई, वो भी चीज इंपॉर्टेंट है, जीरो वाली है ना, कि जीरो ना रेशियो बिगाड़ देता है, वो चीज भी इंपॉर्टेंट है। अदरवाइज सही काम कर रहा है, ठीक है ना, सेंट्रल लिमिट तो सही बात कर रही है। ठीक है।
हाँ सर,
अगर ऐसी, लेकिन ऐसी कोई दिक्कत हो जहाँ जीरो बहुत ज्यादा हो, तो आप उसे ड्रॉप कर दो, कोई फायदा नहीं है, क्योंकि 100 प्लस जीरो मेक्स इट्स एवरेज इक्वल टू 50। दैट्स अ थिंग विच एम्प्लॉय वेरी मच, राइट? यस।
सर एक्चुअली how will the data set knows that zero is absurd value? That's why I'm thinking.
व्हेन यू हैव ए प्रॉब्लम देन वी हैव ए सॉल्यूशन। तो हमने पहले प्रॉब्लम देखी ना, वैसे तो प्रॉब्लम नहीं आई, लेकिन इस तरह की कभी भी प्रॉब्लम आ सकती है जिसमें जीरो बहुत ज्यादा हो आपके डेटा सेट में। जीरो, इफ यू हैव ए जीरो इन योर डेटा सेट, सो यू शुड नो जीरो इज देयर। You should know zero is there with the box plot. Why we do the EDA? Because everything is present using a visualization. A box plot show you this thing, you have this kind of thing appear. So no, God manually in, don't go the manually in CSV file, go through here, go through the
Actually,
histogram.
this is very structured data set, but sometimes like we are random sampling randomly, so there is some extreme values. But when we take the generalized mean of that data frame or data set, then we get all those extreme values included over there. So that's why sometimes we can get this. But
Hmm.
it's my fault. Like
No problem. No, dear. I'm not saying it's fault, but we recover one more new thing. Be positive. We recover one more thing. Why it's mean is not equal to population one. Okay. So always see. No one is perfect in the world. Not you, not me. Everyone can commit a mistake. So with that mistake, what thing we recovered, that how if we have zeros, we emphasis that zero is there. So how these things we differentiated, and if this thing lot of difference, so how are we do for this? Okay, so don't be regret about this one, just enjoy. All right, okay, no problem. Thank you so much. Here, take your dinner. I'm also taking my dinner. Thank you so much.